There are two sets of rules for flying any aircraft, VFR and IFR. VFR stands for Visual Flight Rules and IFR means Instrument Flight Rules. Depending on the weather conditions, a pilot may opt for one set of rules or the other. There are a number of other factors that influence the decision, but for simplicity's sake, it is the weather that make you fly whether VFR or IFR. VFR or See and Avoid. In order to fly VFR, Visual Meteorological Conditions or VMC, have to be maintained. Basically, it means that you cannot fly through clouds and need to keep a safe distance. In some types of airspace, you also have to see the ground. As under VFR, you are responsible for seeing other aircraft and avoid a collision. There is also a minimum horizontal visibility. Depending on the altitude you are flying in, that is between 5 km and 8 km.
IFR, or used to be called blind flying, is whenever VMC cannot be met a pilot with the proper skills, rating, and an IFR equipped aircraft can still perform a flight. In theory, flights can be performed with zero visibility from start to landing. That of course sounds quite scary and certainly puts the flight crew under a lot of stress, which is why larger aircraft for commercial service are not flown by a single pilot. Restriction to flight visibility. Visibility is the greatest horizontal distance at which dark object can be recognized by an observer with normal eyesight or a measure of atmospheric clarity. Some states that reduce visibility are precipitation, blowing restriction to visibility, low clouds, haze and smoke, and the last one is fog.
Precipitation. Rain, drizzle, and snow are the forms of precipitation which most commonly present ceiling and or visibility problems. Drizzle or snow restricts visibility to a greater degree than rain. Drizzle falls in a stable and therefore often accompanies fog, haze, or smoke, frequently resulting in extremely poor visibility. Visibility may be reduced to zero in heavy snow. Blowing restriction to visibility. Strong wind leaves blowing dust in both stable and unstable air. When air is unstable, dust is lifted to greater heights, as much as 15,000 feet, and may be spread over wide areas by upper winds. Visibility is restricted both at the surface and aloft. When air is stable, dust doesn't extend to as great a height as in unstable air and usually is not as widespread. Thus, once airborne may remain suspended and restrict visibility for several hours after the wind subsides.
Low clouds. Stratus clouds, like fog, are composed of extremely small water droplets or ice crystals suspended in air. Stratus and fog frequently exist together. In many cases, there is no real line of distinction between the fog and stratus. Rather, one gradually merges into the other. Flight visibility may approach zero in stratus clouds. Stratus tends to be lowest during night and early morning, lifting or dissipating due to solar heating during the late morning or afternoon. Haze and smoke. Haze is a concentration of salt particles or other dry particles. It occurs in stable air, is usually only a few thousand feet thick, but sometimes may extend as high as 15,000 feet. Smoke concentrations form primarily in industrial areas when air is stable. It is most prevalent at night or early morning under a temperature inversion, but it can persist throughout the day.
Fog. Fog is a surface-based cloud composed of either water droplets or ice crystal. Fog is the most frequent cause of surface visibility below 3 miles. One of the most common and persistent weather hazards encountered in aviation. The rapidity with which fog can form makes it especially hazardous. It is primarily a hazard during takeoff and landing. There are 5 types of fog: precipitation-induced, radiation, advection, unslope, and ice fog. Precipitation fog is the fog that forms when rain is falling through cold air. This is common with a warm front, but it can occur with cold fronts as well, only if it's not moving too fast. Cold air dry at the surface while rain is falling through it evaporates and causes the dew point to rise. This saturation forms precipitation fog.
The radiation fog. This fog forms when all solar energy exits the Earth and allows the temperature to meet up with the dew point. The best condition to have radiation fog is when it had rained the previous night. This helps to moisten up the soil and create higher dew point. This makes it easier for the air to become saturated and form a fog. However, the winds must be less than 15 miles per hour to prevent moist and dry from mixing.
Advection fog is the type of fog formed from surface contact of horizontal winds. This fog can occur with windy conditions. Warm air, moist air blows in from the south. If there is snow or cool moisture on the ground, it will come in contact with the warm and moist winds. This contact between the air and the ground will cause the air blowing in to become cold. Then dew point rises and creates high humidity and forms fog. Advection fog is the type of fog formed from surface contact of horizontal winds. This fog can occur with windy conditions. Warm air, moist air blows in from the south. If there is snow or cool moisture on the ground, it will come in contact with the warm and moist winds. This contact between the air and the ground will cause the air blowing in to become cold. Then dew point rises and creates high humidity and forms fog.
Upslope fog. This fog forms divertically. Divertically is the process that causes sinking air to warm and rising air to cool. As moist winds blow toward a mountain, it upglides and this causes the air to rise and cool. The cooling of the air from rising causes to meet up with the dew point temperature. Fog will form on top of the mountains.
Ice fog. This type of fog is only being seen in the polar and Arctic regions. Temperature at 10 degrees Celsius is too cold for the air to contain super cold water droplets, so it forms small tiny ice crystals. While freezing fog occurs when the temperature falls at 0 degrees Celsius or below than that. This fog produces drizzle, and these tiny droplets freeze when they come into contact with an object. But at the same time, there is sublimation going on.
The visual range of runway. To explain the visual range of runway, it is a distance that pilot could see with their eyes without any obstacle block the visibility. It will be easier to see or estimate the runway. Visual range of runway determined by the pilot side itself. Runway can be clear if there is no fog, smoke, and rainstorm. These three elements could block the visibility of the runway range. Thick fog could make a screen block the pilot and couldn't perform any good landing to the runway. It is also related with another factor such as the age of a pilot, hallucination, and fatamorgana. When the pilot reaches the age of 50 and above, their eyesight will be very and blurred. Weather is also the vital factor. Bad weather also block the visual of the runway range. Haze and smoke are the similar things that block the visual to see the runway range. Lastly, it could be easier to see the runway if there is no fog, the weather are clear, and the good eyesight. It is very related between the fog and the visual of the runway. For the conclusion, the fog and the visual range of runway are very related with each other and very important to study about it.